Сейчас я бы хотела пригласить на сцену нашего первого спикера, Emanuil Tolev из компании Elastic, и его тема Hiring a Personal Investigator for Your App.
It's only my second time in Ukraine. I came to Odessa in March to PyCon Odessa there. And so I'm very happy to be in Kharkov.
Yes.
Okay, more or less. Okay. Привет to everyone. Hey. So just for me to get some idea of how much the intro stuff I should do, how many of you know about the project called Elasticsearch? Okay, quite a few, not everyone, but quite a few. How many of you know about the company called Elastic? Okay, less. All right. Okay, so we'll start there. We got quite a bit of time, and then so overall, what we're going to talk about is application performance monitoring. So I'll start off with a little bit about Elastic, and then like why, what application performance monitoring is, and why you might want to use it, as well as some lessons from me trying to use systems like that. It's actually not our system; it's a competitor system, and like what I learned and what approach I would take nowadays to selecting an APM system. Tolev, the audience will understand Emanuil rather than Emanuil. So I really appreciate that. For Elastic, so I go around and I talk to people about our stuff. We're mostly an open source company, and the vast majority of our things are either open source or they are free to use, so you can get quite a lot of value out of them. And so my job is basically to go around and get people excited about that and get them thinking about what they can do with our projects. So I'll get back to what APM is in a sec. So Elastic itself, it has these 4 open source projects. So the heart of the Elastic stack is Elasticsearch, which is a general purpose open source search engine. You throw JSON documents in it, and then you can get them back out really easily. With like I get about 24 different query types, and you have geo searching, you have text searching, you have metrics. You can store numbers in it and use it like a time series database for analytics. Do all sorts of things. And indeed, the APM system that I'm going to show you uses it as a time series database. So you got a bunch of numbers and some time to plot them on. Then Kibana is a graphical user interface for Elasticsearch, for data in Elasticsearch. There you can search logs. The most common use case for Elasticsearch is to put a bunch of logs from all of your applications in there, and then to put a bunch of metrics like CPU and disk and network activity, and you can visualize them all in Kibana. And there's also an extra component which we'll talk about today, which is APM. Then Beats and Logstash are basically things that allow you to get those metrics and those logs into Elasticsearch. So these are all open source projects. We have also, because at some point our founders realized that in addition to pumping out lots of open source, we will need to actually make money. So we have now decided to focus on solutions. So what you can use this open source for, and a database has endless uses. Like Elasticsearch itself is used in a lot of things. Rover analytics are stored in it. Uber uses it for its matching, when you use a car to match to a driver. Tinder uses it, which is like a different kind of search, I guess. There's lots of different things. So now just thought this might be interesting for you to see from the point of view of an open source company. Like we are now trying to build on top of the open source projects to provide some value so that other people can build on top of our solutions rather than have to build this. It's an interesting business model evolution. But today, a short intro about Elastic. Today we'll talk about APM. Okay, so how many of you have used an APM system? Know what it is? Okay, all right, excellent. So this is a good talk for this audience. So an application performance monitoring system, I will give you a demo shortly, is something that allows you to see what are the slowest transactions, and which bits of your code are the slowest. Like, for example, which database call is slowing you down, like on average, what are the slowest transactions, what is the slowest path or route on your website, that kind of thing. Let's see if I can move this. Yeah. Speakers. In general, when you think about website maintenance and logging and metrics and so on, to me, all of these problems are all a kind of search. So you get up at 3 a.m. as the person on call, as the operator or the developer, and you have a problem. Your phone is ringing with you get a page, and now you have to think, okay, what the hell is wrong with my website, and how can I fix it so I don't get shouted at? Okay, well, I need to now narrow down what this problem is and the root cause. And for me, this is a kind of search. If you look at it from a cognitive skills perspective, you have an overload of information. You have logs from tons of different types of applications. You have like a web proxy and a database and your actual application layer and very possibly many other things, many components, and they all produce that information down and present it in the right way so that we can find out what the problem is and fix it and go back to bed. Okay, so this is not a new problem. If we look at the evolution of this problem, we started with logs. So at least that's how I started. When, I don't know, it was like maybe 12 years ago that my kind of career in web mastering started. So back then, you just had a few different applications probably running on one computer, and you had a log. So in this case, this is an Elasticsearch log file. And you would look for errors if there was a problem, and you would that file, like for that component, and you would look for a problem. So you did a kind of search, but it was quite primitive. Then you would add more machines. So you would probably have something like Nginx or Apache sitting in front, and then you would have the application behind it, maybe a Python application, Flask or Django, and then you would have behind it MySQL or Postgres, maybe Elasticsearch later on. And so you had a lot of different components. Okay, so it's not such a problem. You would log into specific machines. When the site fell down, you would know, at first I need to check Nginx or Apache, and then I need to go in and check the application server, and then I need to go and check the database, and I will eventually find out what the problem is. However, right, the issue is that then you add more and more machines. Like you add more and more, nowadays, containers, previously VMs. We still use VMs, of course. And eventually it becomes unmanageable. So here you can there's some solutions. You can maybe get all of these files together with scp and then grep them all on one machine, or you can rsync them all to one server, and you can search through all of them. But it starts to get pretty difficult, and especially if you start doing auto-scaling, which allows you to destroy machines and recreate them automatically, then you lose the logs. So now you are screwed. So this is a problem. So how can we fix this? Right? We need to get access to this information more easily. And so in terms of the evolution, that's exactly what we had to do. So we had, there were attempts. As I said, this is quite an old problem already. So there were attempts to fix this, like Nagios and Isinga. Maybe some of you have used those tools. So these tools would allow you to centralize the logs from many different machines, as well as the metrics. So things like CPU and RAM use on each computer, and which processes were the heaviest, and things like that. Right. Very old, venerable projects here. But so we had first, it was distributed, the problem, or the logs were distributed, and we chose to federate it all in one place. And we've kept that, so we're still federating. So the thing kind of that came on maybe most heavily about 10 years ago, and then started evolving quite quickly, was that logs and metrics are good, right? They allow us to see to some extent what's going on, but they mostly focus on the environment. Like, the only thing we really know from inside our app is the logs that we make it produce, but we don't know which parts of it are going to be slow, so we don't always log everything in advance. That would be a problem. We don't know what problems are going to occur in production. Really, we want a principal investigator, like we want a detective of some kind. So, I know the talk says hiring a detective for your app, or hiring a private investigator for your system, but it gets you much closer than before. It's maybe disappointing, but we will get back to this later, and I will show you how you can get a real detective for your app. In terms of the efforts for APMs, which make you look deep inside your app and kind of X-ray it, so you're not only looking at the outside of it, like CPU and RAM, but you're looking inside, you're looking at what each transaction is doing. The efforts for that date back to, I guess, the 2000s, really. Is there anyone here who has used Precise, Wiley, or Quest software? Yeah, I thought so, yeah. So nobody ever has heard of these, but it's thanks to these efforts that we have what we have today. What you might have heard of is Dynatrace and App Dynamics and New Relic. Has anybody heard of any of these companies? Yeah, okay, yeah. So this is quite a full space nowadays. There's, I don't know, like there's like a dozen major vendors. So what I'm showing you today applies in general to many of these systems. So let's see the demo works. I'll show you an APM system because it looked like about 70% of the room did not know what one was to begin with. So hopefully we change that by the end of the presentation. Let's see. Okay. I am not very used to working at such small resolution. This is VGA, so bear with me. I may need to resize some windows and do some things. Okay. Right. So let's say that you have some kind of performance. We'll go back to this later, but that tells you users are potentially experiencing a slowdown, or maybe you go yourself by looking at your system. Okay, so here we see this one possible transaction. It says, oh, it's abnormal, more than 100 times slower than usual. Okay, and what we would open as the actual APM system is here. Loading dance. Okay. So this is a pretty typical display. I agree, it's very good. This is a pretty typical display. What's important to notice here immediately is these three different lines. Can you all see them? This screen is really small. You can? Okay. In the back, can you see? Yeah. Okay, all right, well, fine. This is really throwing me off. Okay, so here we have in the blood percentile. In yellow, we have the 95th percentile, and then we have the average line. So if we just look at the average time transactions, there are no, right? They're just is that you have a lot of small transactions that complete quickly because they're easy. However, that doesn't mean that our users are not experiencing problems. So this is why we look at the 95th percentile. So the idea of 95th and 99th are that they are supposed as metrics. They're supposed to give you an idea of what 95% of the users would experience. So not the average experience, but what's a more representative experience as a user. As you can see, there are some significant spikes, and yeah, this number here says 16,000 milliseconds. So some people are experiencing 16 seconds response times. So this is, the British like to understate things. So this is suboptimal. That's what we say. And on the right there, in the blue line, you just have transactions per minute. And then below, this is typical display for any APM system. You will see this in New Relic, Datadog, all kinds of systems, see similar displays. Then you have a list of the transactions ordered in some kind of way, typically by some kind of resource use. So we're interested in what is the heaviest and slowest transactions. So here we can see we have find owner's page, and we have update owner, and they're ordered by impact. So impact is something that Elastic's APM system specifically calculates. Oh, I forgot to mention, so everything that I am showing you here is completely free to use. So you can, it's not a trial or anything like that. There's no limitation. You can be a huge company. I don't know examples of huge Ukrainian companies. So you could be the smallest business possible. You could be BMW or KPMG or IBM. And you can use the system completely for free forever. So I will explicitly tell you if I show you anything that costs money. But so far, you can download all of this, just like Elasticsearch and Kibana themselves, and you can run all of this yourselves. And the way that it works, you download a little agent. So in Python, you would install txt or to setup.py, and you put 2 lines in your config, and it kind of hooks into your app, and it starts looking at the transactions. And then you run a server separately, and the client from your Python app sends information to the server, the APM server. It's written in Go, so you just run it on a separate machine if you're doing it yourself. And then that server sends all the data to Elasticsearch, and then you have Kibana. And Kibana allows you to see all of this. So this is how this whole setup works. OK, so anyway, so here we see a problem. So this is the interesting part of the demo. Let's see if this actually shows the slow transactions. You can do this, which is zoom in on a specific problem. And here we are. OK. So in this case, we have owner's page taking a while. None of these are that slow. Let me see if I've loaded one. Yes, I have. OK, so for this part, so what's happened here, I know exactly what the problem is, but what's happened here is you see this up here, this time selector. It currently is on November 28, 2018, which is when this data. So the issue is that because of the change in time zone, that has thrown off the selector, and it's looking at the wrong range. And for some reason, even if I reselect it to be a much earlier time, so for example, we look from midnight to 5 a.m., here we see some significant problems. And if we look here, for some reason, it's not finding the transactions I expected to find. So I have not had time to debug this because, yeah, time zone problems, blah. However, I do happen to know which transaction is problematic in this case. So I have just opened it. So we're going to cheat a little bit just so I can show you what the problem is supposed to be. But anyway, more to the point, this is a typical view that you would get from an APM system when you open it. This is a detailed view. So what I showed you before is the whole overview. You have which transactions are slow, and you have on the right, you have number of transactions per minute, how many we are performing. So that's quite typical. Now here, well, this is in particular in this system, and probably in others, you have these bar charts. So this is like how many transactions are this fast. They're by buckets. OK, so we have about 120 transactions in this time span that are pretty fast. So here is 2 seconds, here is 0. So this is like 200 milliseconds or so. So these are normal transactions. And here we have 6 seconds, 8 seconds, 10 seconds, 12 seconds. And we have transactions that took more than 12 seconds. OK, so currently I've selected the normal ones, which are taking under 200 milliseconds. And this is also a very typical view, and it's the most useful thing. It's like when I first used New Relic, this really blew my mind that you could see like into the app. It's incredible. And they all do it now. So you have the overall route. That's the update owner. So that's like the action in the controller or the /update owner, however you'd like to imagine it. That's the page, right? Then it calls to this API. And then we have a few different systems calling each other. And then we can see eventually we're issuing SQL queries, and they take X microseconds. And the code itself takes like X milliseconds to execute. This is quite cool. Now, here, this is just an intro talk into APMs, but see the different colors. OK, so I don't know if you probably can't read this, but I'll read it for you. The blue says Pet Clinic React. Pet Clinic is the name of our app. The green says, and the purple says Pet Clinic Spring. The Spring is Java. OK, so we have React.js, so front end. We have backend in JavaScript, and we have Java. So these are 3 different services, right? But we see them all in one graph. This is called distributed tracing. And it's a system that all the major vendors offer. It's quite interesting. So as a request comes in, if you have to have instrumented each service. So each service has to have the little agent I told you about. So in this case, the front end has an agent for real user monitoring. That's what that's called when it's in the browser. And then the backend has the Node.js agent, and then the Java has the Java agent. But when the request comes in the top and the front end, it gets a little diagnostic header with a unique number. And then as it goes through the rest of the layers of the system, they recognize that it's the same number, and they add the diagnostic information onto the request. And so it can chart a path the request took all on one screen. And I love that. I think this is one of the best things to happen to debugging production system. And so if we select one of the spans, they're called, you can see like what lines of code executed that. And if we select the entire transaction, you can see a lot of different information, like what service. So sometimes this is kind of more custom. These systems will have you have user email ID, so you can see actually which user this transaction relates to, which is awesome. Yeah, so you have a lot of metadata. And right, so before we'll get even further down into even more detail. But first, so far we've seen the normal one, right? So OK, it took really a short period of time, only 30 milliseconds. And here we see a breakdown that goes down to the microsecond. So this is like extremely fast code. OK, so let's select something that took 13 seconds. So at the very end. It's loading at the top. OK. Right. So this breakdown looks different. So first off, the transaction took 13 at the top. And then we see all of the services really took 13 until we get to this. It says validate zip code. OK. So if we open this here, we see, the result is HTTP 4XX. So they got a client error here. And if we look inside, the resolution is a bit, we can see here HTTP response status code was 400. Bad request. Data, possibly. And we see, OK, there are some specific line 12 and line 33 in our zip code validator.java. And for some reason, that function 30. So far, looked at itself, but we already have some ideas. We know that the client sent bad data, possibly, and well, we don't know that yet. So the client sent bad data, and the validate zip code function took 13 seconds to execute in the case where the client sent bad data. That's all we know so far. All right. However, we can also see that it's what I also like about it is very visual, right? you can see, okay, the trace is different to the normal trace. There's an error there. It stops early. So that's a better way of diagnosing, much more visual way of diagnosing this kind of problem than if you had to, go into the logs and try to figure out exactly what went wrong. And the logs are just scrolling with messages because you have 1,000 users on the site, and that's quite a pain. So the other thing I want to show you is the ability to see errors. So all of these systems, like APM system, will group error. We have no message available, uncaught range error, like, okay, various types of errors, and you have occurrences. So you have 75 of this kind of error, 30 of this kind of error within the time span we selected 4 hours on the 28th of November last year. And you can see another bar chart of how many the errors you're getting in a certain time. All right. That's just another like super important feature. So if you are not using an APM system, you should use one, because like even like look at all this stuff you get for free so far. Like it's fantastic, but I think it is at least. So, all right. So let's have a look at the site itself. Oh, tiny resolutions. I guess APM, right? So we got the alert. We looked in the system first, and now we have some idea that it's to do with validating zip codes and it's to do with updating owners. So let's have a look at that. Okay, well, it said edit owner, so I will just pick one. Wait for it to load. Okay. George. Okay, so update owner. All right, we're editing the owner. Zip code. Yeah, okay, that looks normal. No problem there. So it said bad data, right? If we have a look at the transaction, at information, and this is what I like about it. So I can barely see this, so I can only imagine you can see. Okay, there you go. Okay, this is a bit more readable. All right, so let's see what we have. We got user agent. Oh, we have looks like one of my colleagues was playing with this website. Have the port, the schema, the exact route, the exact ID. Oh, looks like the APM system and into the headers. Okay, so it says object name owner, field name, zip code, field value, blah, 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 error message invalid zip code. Okay, this is definitely not a valid zip code. For the US, it looks like it's like 30 characters long. Right, so if we try that, and it has letters in it. So if I just try to make it invalid first, so let's first try a normal case, right? I just changed the last number from 4 to 5. Okay, that's okay, that was not a problem. It's not slow, so what's going on? Okay, let's replace the last. Cheers, thank you. Let's replace the last. The last number with a letter. Okay, invalid zip code, but it's not really taking that long. It's still working okay. Okay, that is just the Wi-Fi, I think. Yeah, this is definitely the Wi-Fi. I agree, it is very unfortunate. But if we use his string, this is also slow. The problem is in this case. So anyway, can anybody guess what the issue is here? Like, why is the zip code validation taking so long? Huh?
Probably it's minus. I guess it's because of regular expression.
Regex. Yes, exactly. Whoever said regex wins. You can have a sticker I have Elastic stickers afterwards. But yeah, even if we try this a few times, even on like fast Wi-Fi, you're going to get this problem over and over again. So you've essentially been able to replicate the problem much more easily, pretty much directly out of the diagnostic, rather than having to guess which page might be slow, what might make it slow, and so on and so forth. And now that you have a reducible problem, you can file your bug report, and all good from here on. So there is something else that I want to show you. So in the beginning, I said, let's do that. In the beginning, I said, let's say that you get an alert from your system. Okay, so clearly, this is not like, this is a bit hand-wavy, right? Let's say, but how do you set up alerts at the right thresholds and so on? So it says here, users are experiencing slower times than usual. This job detects poor performance in the browser. What job? Okay, so this part of the system that I want to show you is commercial. But the reason I want to show it to you is because I think that we need to think of what to do in the monitoring space, in the troubleshooting space. And anything that is commercial will eventually become free, right, as it becomes more and more of a commodity. But there are two things that I'm quite excited about. One of them is machine learning on this data, because I think machine learning techniques, I mean, especially in this community, you would know, machine learning techniques have advanced quite a lot. So you could run this yourself on the metrics. It's just that Elastic has built a system to do it specifically who can pay for it. And then the other thing is knowledge. There are competitors of ours. We don't have anything like that. There are competitors of ours that have built things like, so say, what's your name? Irek. Yeah, okay. So say Irek is like the senior sysadmin or operations person, and he helps maintain pet clinic. And then I am his apprentice. I've been hired like 3 months ago, and I'm still making Irek coffee. But Irek wants to teach me, yes? And so Irek has to get up in the middle of the night because he's tier 1 on call. He's the first line of defense against problems. And so for now, I am not on call, so I'm still asleep. So, okay, so Irek fixes some kind of problem, right? But then Irek wants to tell me what he did and what he looked at to understand what the problem was and how he fixed it. And Irek could record all of this information in a Google Doc or something. And indeed, that's what we used to do. I used to run a small company. That's exactly what we used to do. When I had to train someone, that's what I did. But so one of our competitors, Honeycomb, has a feature that it allows you to, it shows it to other people that are using the system. So I can log in later, and it will tell me, or Irek can send me a link, and it will tell me, Irek was looking at these graphs, like at this specifically. And it will record information. And so I can learn more that, right? Imagine the evolution of that feature. You could have these systems could be plugged into some kind of knowledge base or knowledge store where you essentially generate playbooks for disaster response from the system. And so rather than having to take screenshots and copy paste difficult tables, lots of headers and all of this crap, the system itself allows you to generate the disaster recovery information. And it allows you to train people and maybe allows you to share knowledge between the different sysadmins. And so what lives in the head of the sysadmin part of the system is that knowledge. That's an exciting feature that we don't have. However, I'm glad that somebody is working at least on the beginnings of it, because that's one direction I think the evolution of monitoring could go in, right? And so the other one is machine learning. So here, and that we do have. So this, anyway, this is a long way to tell you that this is why I want to show you this. That's why I'm excited about it. Not really from the perspective of, oh, you can give Elastic some money, but rather it's a unique feature for the evolution of monitoring. Okay, so here a machine learning job has sent this alert because it thinks there is a problem or there will be a problem. Okay, and so this is what our interface looks like. So this like swim lane interface. So it says the red is the worst parts, so which is quite helpful. The whole point of this is that you can quickly start to understand where the problems are. So it's a bit too small resolution to see here, but actually user.name, so it will extract correlations from the data. So for example, which users have the slowest transactions? So which are the slowest transactions? So here we have update owner. This is actually how I knew, like back when that part of the demo screwed up, this is how I knew that it was the slowest transaction, right? Because it's in machine learning data, but and so we have a problem here, and this is the slowest one. Okay, so we have a possible user, that's the problem, and the possible transaction, that's the problem. And all of this is extracted automatically from the data. So there is no labeling. Like as an operator, I did not tell it to look for transaction.name or to look for user.name as variables. It's included in the data that it gathers, and maybe I can say start gathering user.name as a custom tag, but it didn't know that it had to look at those attributes. I didn't specify, tell me which is slowest by user.name, tell me which is slowest by transaction.name. There's a piece of machine learning in there called supervised learning. It uses several different algorithms, so unfortunately I can't really be that more specific in the length of this talk, but this is roughly what it looks like. So you give it like 2 weeks of data, I believe it needs to begin with, and then it generates this model, and then it will detect anomalies. And it assigns the anomaly score itself. So it essentially learns what is normal operation, unsupervised completely without any labeling or test data, and it gives you anomalies based on that. And it seems to work fine. Like, a lot of people give us money for it, so I guess it's useful. But yeah, anyway, that's the other possible kind of evolution path for monitoring that I've seen. You've got knowledge sharing and you have machine learning. Okay, so back to the slides. So really interesting giving this talk without any speaker notes because I have to mirror the display for the demo. You have, how long do I have roughly? About, do you know? How long do I have roughly? About 10 minutes, yeah. Very good, excellent, okay. So, just to recap quickly, an APM system is something that shows the best and the hungriest transactions. That's for those of you who have not used one before, you can remember it with the 2 turtles. So you should definitely use one. I don't care particularly which one you use. You can use the free one by Elastic, or you can use one of the other ones, but you should use one. It significantly reduces pain for you. And if you're an operator, if you're a developer, you should help your ops people get it. Or if you have a DevOps shop, then you should all get it. But install something, please, to make your life better. It conforms to open efforts and standards. So there's a project called Open Telemetry, and there was a project called Open Census. So this is more like almost vendor selection. Be aware that there are open standards in the space. So try to pick something that supports them. They're cross-vendor collaborations, and they allow like systems to be more interchangeable and the components to be more interoperable. Yeah, cool. So the problem with an APM system, though, is that just like the logs and the metrics, it can remain it can remain just a bunch of graphs that you log in and you shake your fist at because you don't know what's going on. It is totally possible for that to be the case. The level of detail and the level of depth it hooks into an app does make it more useful by default than a CPU graph, but it will be overwhelming and not very useful. So the way to make it useful is, unfortunately, there is no magic bullet for it. You are the ones who make it useful. So here I want to tell you about a bit about my experiences in the past with APM systems and what we could have done better to make them actually useful. So I had this client when I was running the British friends, and we had this client, Open Science Catalog, a catalog of open access scientific articles that you can read for free. We wrote it in Python, so we were the technical partners of this non-profit organization. They were all work and all the actual science management work. and we were I was on call 24/7 for 4 years. Great. So anyway, at some point, we got tired of not being able to, of not knowing what's going on inside the app. I remember one time where we had a recurring problem for 4 days, and I got pinged about 3 times per day. And this was also during a meeting for another project. So my life was great during those 4 days. The 9th of October to the 13th of October, I won't say which year, but I remember it quite clearly. So at this point, we were like, okay, we need something more than logs and CPU metrics and RAM. And we installed New Relic Lite, which is version. So the thing about it is that 24-hour retention, and of course it was much better than nothing. Like, my life was instantly changed. We solved the problem, and we solved many other problems afterwards. However, later on, we started having recurring problems that we couldn't solve by just looking at New Relic. And I mean, that's no surprise, right? But what we should have done is... maybe let me tell you a bit about the problems first before I get into what we should have done. So the particular problem that we experienced that wasn't really a technical problem had actually to do exactly with training and root cause analysis. Because it's 24-hour retention, if it happens on Saturday morning, you don't have the data by Monday morning. Okay? So, and we needed it. So we did all sorts of stupid things like screenshot the New Relic interface and record, write down information. It was just a pain. Now, okay, right, sure. Obviously, the point of that is to pay the vendor, and then you can get the data. But this was a non-profit, if you remember. And I did try convincing them to pay for it quite hard, but they would not. Okay, so at that point, what do you do? So here, what we should have done is we should have sat and 6 to 12 months after we first installed it, and we should have reflected. What is New Relic doing for us? What is it not doing? Like, is it going well? Are there problems that are surfacing that it can't solve? Should we change vendors? Like, we should do something, right? Because this is exactly the evolution so far. You had logging, and that was much better than having no logging. But then you had some other problems. Okay, but so there are errors in the log. It just says out of memory, and the kernel says the OOM killer has reaped our app. Okay, but why? When? We don't know. Okay, so so you add metrics on top. So you have CPU and RAM. All right, good. Okay, well that's not enough. We don't see very deeply into the app. So we have APM systems. Okay, so we have that. Okay, well so now we have this particular vendor that we were using, but we're starting to have a problem that we can't solve with the retrospectives. So we should have thought about what the next step is. And there was a next step, actually. There were other vendors that were cheaper. So we could have, and they would have paid for that. They would not have paid whatever it was costing for New Relic, but this other vendor was much more specific. It was only for Python. It was a small startup. So they had much more aggressive pricing, like 10 times less at the time than New Relic. So they would have paid for that. And we could have used it. But we should have sat on our asses, thought about, do we have any problems, and then gone and researched. But we did not do that because ops people. So I don't really know why we didn't do it, but you should do it. So if you have such problems, you should sit down and think. Quickly, there's just another quick case study. See that this, 2 anecdotes becomes data, right? Kind of. So this is. And we had New Relic Lite, and we're using New Relic Lite and Regan. Regan is like an error collection thing. Again, we had and so here we had different kinds of problems. It wasn't the retrospective so much. It was also a problem. But here we were making a lot of use of my because like New Relic Lite doesn't give you the database transaction in depth diagnostics, but New Relic Pro does. And this was a startup. Right, so like, you could have afforded it. If I have that, I don't have it here. Okay, so I'll tell you the actual numbers. New Relic quoted us £400 a month. So I guess, yeah, about whatever. At the time, maybe €500 a month for New Relic Pro. We were quoting the client $450 per developer day. Okay, so pretty much 1 month of New Relic is 1 developer day. do you think, like, how long, we spent a lot longer than 1 developer day per month trying to diagnose transactions. That which could have diagnosed easier with New Relic Pro. This made no sense at all. They were paying us for the time, and they thought, oh, well, New Relic is too expensive. Cool. But actually, they paid so much time by just paying that price. So, yeah, this is something to learn from, let's say. But anyway, in terms of the lessons, so just to let the moderators know, maybe a minute over, but we'll just take a few less questions if that's okay with you. I'm almost finished. All right, so lessons. Be intentional about your systems. Don't just install something and then let it sit and don't fix the problems that come up. If you encounter further problems, sit and think why you're getting those problems and how you could solve them. You want to switch vendors, what do you want to do? Think about why you installed an APM system in the first place and how that's going. Keep reflecting. Another useful question that I now think on reflection would be very useful is, do you keep learning something unexpected from your system? In the beginning, when you install it, it'll be every day. Then it will be maybe every week. Then it could be every month. But it should be teaching you something about your system that you did not already know. And then you should also think regularly, where do you want to go next with your monitoring? I know you've got lots of other things to do in your job, but maybe every 6 months or even every 12 months, just think, could we improve this monitoring? Has anyone gone to a conference or heard something useful? You know, can we do something else? Where should we go with it? How do we improve our monitoring? And think about that proactively so that you don't do it after 4 days of on-call, of being paid. Everyone is testing in production, even you. Even if you have a testing environment, you will be testing in production. So learn a normal production behavior. Like the ML algorithm, learn a normal production behavior so that you know what it looks like when it's on fire and what the differences are. And that will save you a lot of time to recover. So log into your APM system just on a normal day and have a look. With your morning coffee in the office. So if I had to pick an APM now, that's roughly what I would do. Write down the existing problems and the value of solving them, because you'll need to talk to business stakeholders to hand over some money for these systems. Actually, so Elastic's APM system, in case you didn't want to run it yourself, because you have the who watches the watchers problem, right? Who monitors my monitoring system? So the Elastic, then you have all of the vendors that are only SaaS anyway. But then think about the value of dev time. And I already gave you an example where we could have saved a lot of money with dev time. But there's also creativity and happiness. If your people have to do the same thing over and over again, that's a problem. Right? They're not going to be particularly happy doing grunt work endlessly. So try to get a system that automates the toil, as we call it, toil work. Think about what the existing skills are and the tech. You know, it has to be compatible with your tech stack, obviously. Like Elastic APM doesn't have a PHP agent, so obviously you can't use it for PHP at the moment. We hired a person, so it's coming at some point. If they already know a certain system, like New Relic or Elastic, then it might be worth you keeping with that. That's an amazing device. Then, of course, you have the price. And then, this is really useful. Pick 3 vendors and then narrow down to 1. It will force you to think, right? Then you don't get excited by a talk like mine and you go, oh, I should install Elastic APM. Ah, great. No, pick 3 vendors and compare them. That will make you think about your own needs. That's the point. And then you can do the, why did I install the APM? In 6 months' time, you can reflect, why did I install the APM? Did it solve my problem? Where should I go next? But this will force you to action. So this is really useful. So finally, I promise in your applications, there is no tool that is a detective or a personal investigator. That it does not exist. Anybody who tries to sell you one is lying to you. You are the detective. You are the personal investigator. You wield these tools, be it systems. But last, it will always you. Your systems, you know them. It's your job to know them. It's probably your passion to know them. So you're the detective, and yeah, good luck with all of your systems and all of your tooling. Thank you.
anyone has any questions?
Thank you for your presentation. And my question is, if I put my application logs to the same Elasticsearch cluster when my APM data goes, is there any way how I can connect APM data with logs, that when I select some data, some span, I can get this related logs to this time series?
Yes. It doesn't work flawlessly, but yes, there is a button on there that says view log for transaction.
And okay, maybe it's more technical. Can I reach you out after?
Yeah, we can have a look. Yeah.
Thank you.
Yeah, I can show you. Yeah, one of the points of the one of the points of putting all of this together, like machine learning, the logging, the metrics, and the APM all in one stack, that's actually our company strategy, is to eventually integrate all of this stuff together, because that makes it even more useful, right? It's like the same data that you would do otherwise in different systems, but if you put it in one, then it's all integrated together. So you can do things like that, correlation.
Thank you so much for your awesome speech. I have at least two questions. For example, we have a distributed application that have the same nodes under the load balancer. And is it enough to set up the agent that looks for performance metrics only on one, assuming that the rest of the nodes are the same?
Well, you will only get data from that node.
Yes.
In that case, I mean, you could, and that'll give you a sample. It'll be better than nothing, but it has pretty much no performance impact, or extremely little. That's the primary thing we benchmark for, because we don't want to affect production for users. So I would personally, I'd install it on all of them. If you have to.
As far as non-New Relic charts, you've per agent installed on the node. So
yes.
You can just save some money using only one agent on one
okay,
node.
so you could, yeah, if you're using New Relic, then yeah, this is one thing that you might have to do, and then you have more of a sampling approach, so you don't look at all of your system, but you could miss problems. So Elastic doesn't have that approach, so even if you buy an Elastic Cloud, you're actually kind of just paying for the data storage. You're paying for the server node, so we don't have per agent pricing or per server pricing at all.
Okay.
So it scales in a different way, so you would not have that problem if you use
Yeah, I see. Another one question is related to sensitive data. Like you probably know, I'm pretty sure you know about the GDPR law that forces companies to not store personal data on third-party servers or something like that, and to be pretty aggressive about saving the restricting access to this data. Is it possible to configure this application monitoring tool?
You can blacklist fields. Yeah, it's in the config for the agent.
Yeah, thank you. Thank you so much.
Very well.
Any other questions?
Making it easier in a run along.
I'm just curious, what was the regex first example?
Come find me afterwards. It'll be a bit difficult to show it to you right now because I don't have the code cloned to my PC.
Okay.
But yeah, I can show it to you.
There's